Hello all and a very warm welcome to Mathematics School. In this video, I have for you a very innovative question from International Math Tournament that actually going to help you learn how to correlate the binomial coefficients of binomial series for positive integers and that for any rational index. So let's quickly go to the question. The question says evaluate the infinite sum. Sigma n is from 0 to infinity, 2n cn 1 upon 5 whole power n. So before actually starting the question, let me tell you the symbol 2n and n written within the parenthesis like this implies 2n factorial divided by n factorial n factorial. So this is the first thing that you should know while solving the question. Okay, now let us proceed with the question. To get the sum of this series, I'm going to start with the expansion of 1 minus x whole power minus n, where m is an integer that I have taken, or in fact m can be any real number. It can be fraction as well. So now I'm writing 1 minus x whole power minus m expansion, only keeping in mind that mod x ka value is less than 1. Proceeding with 1 plus. The expansion turns out to be 1 plus minus m into minus x. Then we have the next term minus m multiplied by minus m minus 1 whole divided by 2 factorial into minus x ka whole square. Coming to the third term, which I'm writing over here, this is minus m multiplied by minus m minus 1. The next factor, minus m minus 2 divided by 3 factorial and multiplied by minus x whole cube and so on till infinity. This is the expansion for 1 minus x whole power minus n, which I'm going to write in the sigma notation form. So when you express your answer in the sigma notation form, what we are going to get here is, I'm using this parenthesis wala symbol, so I can write it as minus m n minus x whole power n, where the value of n starts from 0 and goes till infinity. I'm taking m to be any rational number, fraction, it can be a fraction as well. So it will go towards infinity. As long as m is or minus m is not a positive integer, we will be getting infinite terms in the series expansion. Okay, fine. Let us mark it as 2. So minus m comma n. You can verify this one. What exactly is it? Minus mn. Written within the parenthesis means you are actually going to write it as minus m, then minus m minus 1, minus m minus 2. Keep writing till you get minus m minus n minus 1. So n minus 1 when you subtract, it will ultimately look like minus m minus n plus 1 whole divided by n factorial. This is what we are using. Now you can keep putting the values of n and you can verify yes, what we are getting is similar. When I keep n equals to 0, I'll get the coefficient of the first term. When I keep n is equals to 1, I'll get minus m. When I keep n is equals to 2, I'll get minus m minus 1 upon 2 factorial and so on. So this I have explained it a little how I have used this symbol. Well, I have marked it as 2 and now we are just going to relate it with 2n cn or 2n n written within the parenthesis. Coming back to the question in which you have seen that what we have to evaluate is sigma n is from 0 to infinity 2n n 1 upon 5 raised to the power n. So here is the question that actually now we are going to solve. What I'm going to do is I'll concentrate first of all on 2n n, 2n cn. That is, this is nothing but 2n factorial upon n factorial. I'm going to write the numerator. 2n factorial means you can write it as 1.2.3 up to 2n, continuous product of all these numbers. I will be separating all the even numbers 2.4.6 till 2n and all even and odd in fact I have separated. So till 2n minus 1. Denominator is n factorial, n factorial. So these are the important steps that I'm writing here. So please concentrate. Now look at these n terms. From each of these n terms, I can take 1, 2 ka factor common. What we are going to left out with is n factorial. And after that, what we are going to left out is with 1.3.5 till 2n minus 1. Coming to denominator, it is n factorial, n factorial. 1n factorial from numerator denominator got cancelled, and now it will become 2 power n upon n factorial. Now comes the most important step of this question. What we are going to do next is look at all these terms. From all these terms, I'm going to take a factor of minus 2 common. Yes, we know that there is no minus 2 in any of these numbers, but still I'm saying please take minus 2 common from all of these terms. Because n terms are there, I will be taking minus 2 power n common. But if you are taking minus 2 power n common, then what all will be left out? The first term will convert to minus 1 by 2. That means instead of 1, now I have minus 1 by 2. Instead of 3, it will become minus 3 by 2. And similarly, the last term will become 2n minus 1 upon minus 2. This is what we are getting. I'm going to write it in a little symmetric way. What is that symmetric way? Let's see. 2 power n upon n factorial as it is. Minus 2 power n. Then come to the first term, minus 1 by 2. This minus 1 by 2 I'm going to write as it is. But when you look at the second term, minus half, minus 3 by 2, that I'm going to write as minus 1 by 2 minus 1. The third term is minus 5 by 2, which can be written in this form. Keep writing till you reach the last term, which will be minus 1 by 2 minus n plus 1. You can just concentrate. You can just verify that yes, what I have written is absolutely correct. Isn't it something like m minus 1, m minus 2, m minus n minus 1, right? This is something like that only. So I'm going to replace upon n factorial is also there. So first of all, in the next step, I'm going to club these two. I'll write it as minus 4 whole power n. Now I'm going to club the terms, these. I will be replacing it with the parenthesis symbol, and I can definitely replace it like minus 1 by 2 n. We have just seen how to interpret the symbol. Now I'm using that symbol, or I'm just representing the whole expression with the symbol minus half and n written within the parenthesis sign. This is the value of 2n, cn you can say, or you can say 2n n written within the parenthesis. That is what we are getting here is 2n n is equals to minus 4 power n minus half comma n. Now I'm going to put this value back in the question. What was the question? I'm going to write it. The question was like this, where n was moving from 0 till infinity, 1 upon 5 power n, which now can be written as sigma n is from 0 to infinity, minus 1 by 2n, and then I have minus 4 power n divided by 5 power n. Or you can also write it as sigma n is from 0 to infinity minus half n minus 4 by 5 whole power n. I'm just going to mark it as a star relation because after this star relation, I'm going to write down my final answer. So let us compare this star relation with once again the relation that we have derived earlier for 1 minus x whole power minus m expansion. Just look at this one. So the relation 2 I'm going to compare with the star relation. When you compare them, you will realize that the value of x and m can be identified, and value of x and m, if you identify that, what we are writing here is actually 1 minus x whole power minus m. So once you get the value of m and x, you can identify the answer as well. So okay, let us go back to that star relation. Comparing it with the 2, equation number 2 will give me the value of n is as it is. So I'm going to write 1 minus. What about x? You can see the value of x turns out to be 4 upon 5. So this is 1 minus 4 upon 5 whole power minus m. But what is m here? So you can see that m is minus half. M is minus half. So now what do we have? We have here 1 minus 4 by 5 raised to the power 1 by 2. M is half. What we are getting is m is equals to half, x is equals to 4 by 5. Putting it back in that second equation, I compared it with the second equation and accordingly I am writing my form in this form. Calculate this one. The answer finally turns out to be root 5. So here is the answer for the question that we were solving. Wow, what a creative and beautiful question. I hope you must have enjoyed this problem as much as I have enjoyed it solving. So please share the video and like the video as it motivates us to keep posting such quality and classy questions on our channel. Do subscribe our channel. Keep learning. Bye-bye.